page 63. Go ahead and number this page 63. Complete your name, the period, and today is the 26th for the date. This is our sample problem when we solve problems involving conservation of energy or the mechanical energy. For those of you who have already completed your roller coaster paper, you should be able to understand the process on how to solve. Okay, so the problem says that we will solve for the maximum speed of a skier at point A on this track. There's 3 points, B and C. Skier's mass is 50 kilogram and his speed is 4 meters per second. Well, it's actually a she. Alright, we'll go ahead and put our symbols. 50 kilogram should be the M and your speed is the V. And all of 10 meters, 6 meters, and 4 meters are the H's. So those are the H. Okay, when you solve problems like this, it's important that you need to start with where is the starting point of the skier or whatever object. In that case, it could be a marble or whatever object you have. So at point A, to solve for the potential energy, we all know that's mass times g times height. Solving for that, PE will be equal to mass of 50 kilogram multiplied by the gravity, which is 9.8 meters per second squared. It's always 9.8 times the height at point A, which is 10 meters. Alright, get a calculator. We will have 50 times 9.8 times 10 will give us 4,900. So the potential energy at point A is 4,900 joules. Remember that at this point, the skier is already moving. So now we'll solve for her kinetic energy. Kinetic energy is mass times the square of the speed divided by 2. That would give us KE equals mass of 50 kilogram times the square of her speed, which is 4 meters per second at point A. We square that and we divide the whole thing by 2. Alright, in the calculator it should be 50 times 4 squared. You can enter that and divide the answer by 2. So that would give us 400. Kinetic energy at point A is 400 joules. Alright, now for letter C, you will solve for the mechanical energy or the total energy of the skier at point A. You will add the potential energy and the kinetic energy at that point. So, since we already know both, we plug in the numbers. Potential energy at point A is 4,900 plus 400 joules. And when you plug that in the calculator, you will get, I have already 400 plus 4,900 will give us 5,300. So the total mechanical energy at point A is 5,300 joules. Okay. Now, it's important to understand that after you've found the mechanical energy of your object, that mechanical energy, according to the law of conservation of energy, remains the same. So we will label that. This remains the same at any point. That means that at point B and C, your mechanical energy is also 5,300. Alright, letter D. Now we will solve for the potential energy at point C. Why at point C? Because remember, we're looking for where on the hill does she achieve the maximum speed. And from the animation and the PowerPoint yesterday, Remember that your speed increases as your height decreases. So since 4 meter is the lowest point, that's also the point where she should have the fastest speed. Lowest point, fastest speed. Alright. So solving for the potential energy at point C, again the equation is m times g times h. PE at this point will be 50 kilogram times 9.8 times 4 liters. Okay, plug it in the calculator, you get 50 times 9.8 times 4. Potential energy is 1960. So this is equal to 1960 joules. Now, since we already know the mechanical energy at point C will also be 5300. So you will use this equation here where you subtract the mechanical energy from the potential energy to solve for KE. You only do this if you do not know the speed at that point. In this case, we don't know the speed at point C, but we do know the mechanical energy at that point. So solving for KE at point C will give us mechanical energy of 5300 minus the potential energy at that point, which is 1960. That will give us 5300 minus 1960 give us 3340. So 3340 joules is the kinetic energy of the skier at point C. Alright, now that we know the kinetic energy at point C, we can go ahead and solve for the speed at that point. The equation is square root of 2 times KE divided by the mass. So we will put the numbers for that. That would be 2 times 3340 joules kinetic energy divided by the mass of 50 kilograms. Alright. So on your calculator, you will press second function x squared. Will give you that. Now open the parentheses again since we're multiplying on top. 2 times 3340, close the parentheses, divide that by the 50, now close it again. That will give you the square root of the whole thing, and the answer is 11.6 when we round that off into the nearest tenth. So 11.6 unit for speed is meter per second. 11.6 is greater than 4 meter per second, so we know that that's the fastest speed at that point. Alright, there you go. So take note of the process that we're doing here. For you to be able to find the speed at any point, B or C, you need to get first the potential energy and kinetic energy from the starting point. And from those two, you can get the sum, which is the mechanical energy. Right after you get the mechanical energy, you will use that to get the kinetic energy at any point on the track, provided you already know your potential energy, because kinetic is mechanical minus potential. And right after you get your kinetic energy, you can go ahead and use that to solve for your V, which is square root of 2KE over M. Same process as what you did on your roller coaster. Now, for the last question here, it's asking us, how far up the other hill will the skier be able to go? First of all, remember that the skier is already moving. So, if the object is already moving, what you need to do is use the equation, which is mechanical energy at that point will now be the sole energy that she will use to go up the other hill. So we can say that could be the PE, which is equal to M times G times H. Okay, that's the PE there and the KE actually together. Okay, So the whole energy of the object will give us the height. Okay, so to get your height there, you will use H will be equal to the total energy divided by M times G. So since the total energy at that point is the mechanical energy, at point A, again, your total mechanical energy is in letter C, which is 5,300. So we go 5,300 joules divided by the mass, which is 50, times the G, which is 9.8 meters per second squared. Okay, plug that in your calculator. The object is already moving, so 5,300 divided by, open that parenthesis at the bottom, will give you 50 times 9.8. Enter that. She can actually reach a height of 10.8 meters at the other side of the hill, since she's already moving. Okay, and this is only possible assuming there is no friction on the track. Now, look carefully at the second step that I will show you. What if the object is not moving? If the object is not moving, so in this case, your mechanical energy will only be equal to potential energy because the KE will be 0. Alright, so at this point, your H can be solved by dividing the PE with mg. Okay, it's no longer 5,300 as your energy, but it's only the potential energy. So when we go up, your potential energy is only 4,900. So with that, you can write 4,900 divided by 50 times 9.8. Okay, 4,900 divided by 50 times 9.8 will only give you 10. So in other words, if the object at point A is not moving, the object can only reach 10 meters on the other side of the hill. But if the object is already moving, and in this case, she is already moving at this point with a speed of 4 meters per second, that speed will give her an additional momentum, and so she will actually be able to reach 10.8 meters. Without moving, it will only be 10. Okay? Look at this process carefully. You can always review and rewind the video, but you will follow and use it to solve your next worksheet. You're on your own. Practice problem number 2. This will be page 64.